The quest for a net zero carbon future, the power sector is experiencing surge in groundbreaking technologies and approaches. This session delves into cutting-edge innovations set to transform the power sector's sustainability journey. It highlights the use of artificial intelligence, machine learning, blockchain advancements in grid-edge technologies, new cabling methods, and the concept of grid-integrated energy-positive buildings. The session provides a platform to showcase and discuss these innovations that are reshaping the power sector and collectively driving it towards a sustainable net zero carbon future. The discussion points are AI, ML, and blockchain in power sector, grid edge technologies, new cabling methods, digital twins, AR, VR, metaverse-assisted reality tools, and its application in the utility sector. Before I start, I would like to make the announcement which I made just before dispersing. If in any case have you missed, the announcement is regarding the evening cruise dinner, which is today from 7:30 p.m. to 10:30 p.m. Buses will depart from Le Méridien Convention Center at 6:30 p.m. Ships will leave from Marine Drive Jetty, which is next to High Court Water Metro. Initially, the plan was to hire a larger ship that could have carried 250 people at one go. Unfortunately, that ship's under repair and inspection could not be completed. Henceforth, we've hired two ships, one with a capacity of 140 and another with 100. ISGF and KSCB team has distributed the 240 guests into the two ships. Both ships will go parallelly and will have the same facilities and food, drinks, and entertainment programs as planned for you. The cruise tickets with each person's names will be available at the registration counter right about 3 p.m. onwards. Please collect your tickets and cooperate to maintain the schedule. So let us begin the session as of now. I would like to invite the chair of the session, Mr. Sanjay Dubey, Principal Secretary, Energy Department, Government of Madhya Pradesh, to please come on to the stage. Shri Sanjay Dubey. May I invite the moderator of the session today, Ms. Reena Suri, Executive Director of ISGF. Please put your hands together to receive Reena Suri ji onto the stage. May I quickly invite the speakers of the session, Mr. Devanand P., Chief Tech Services and PSCC, Chintamani Chitnis, Head Power System Control, Tata Power Company Limited. Welcome, sir. The second speaker, Gopal Naria, Head Project Monitoring, BSES, Rajdhani Power Limited. Preetham Mupuri, Business Development Manager, AWS India. Manish Patel, Senior General Manager, Business Development, APAR Industries Limited. Mr. Sunil Kumar, Head of Business Segment, IASEA, SK Senapati, Head Sales Commercial Services, L&T PTD Digital Energy Solutions. Meenakshi Vasisht, Co-Founder and CEO, Tech Uncorked. Vetrivel Kupasamy, Senior General Manager, Schneider, do I say that Schneider? Yes. Electric, and Rahul Sethi, Founder, Metaverse 911. Ladies and gentlemen, please put your hands together for our session speakers, moderator, and the entire panel. Over to you, Reena ma'am.
Very good afternoon. I welcome you back to the session, the fourth session, it's the sixth session of Distribution Utility Meet, which is going to talk about the new innovations for the net zero power sector that we are experiencing. So as the power sector strives for a future with net zero and net carbon emission power sector, it's experiencing a huge uptake of new technologies, pioneering technologies and strategies. And ISGF has also been working actively on engaging with the wide range of new technologies that are coming into the sector, fostering new innovations and technologies for achieving the net zero power sector in India, which our Government of India is aiming for. So today with this session, we delve into cutting-edge technologies and approaches that are shaping the future of sustainable power generation. Our discussions, generation, transmission, and distribution, and our discussion today will be, with our eminent panelists and speakers that we have. We'll be taking their experiences about the new technologies that the power sector we are working with, from AI, ML, blockchain, and the grid edge technologies that are around. We will also be talking about innovative cabling methods and the concept of grid integrated energy positive buildings, and so on and so forth. And also our speaker will be talking about another verse, which is a metaverse, that kind of experience that he's going to bring to us. So with the new innovations that we are seeing, we collectively are looking forward to a very power-packed discussion today. A very informative session is in the progress, and we're looking forward to hearing from all our speakers. So before I start this session, I would like to invite our Honorable Chair, Shri Sanjay Dubey ji, Principal Secretary, Energy Department, Government of Madhya Pradesh, to please deliver your chair address. He has an extensive experience, and I'm sure there are a lot of innovation that he's bringing to Madhya Pradesh and overall power sector that with the experience that he holds. And we're looking forward to hear from you, sir, what innovations you're seeing and what you're looking forward to. Over to you, sir.
Thank you, Mansuri. Honorable speakers on the dais and participants of the dais. I know when we talk about power sector, I think it is the only sector probably which is seeing the transition at a scale which is unprecedented. Not very many government departments, not very many utilities, whether it is urban utilities or electricity utilities or any other utility service providers, are using technology to the level that the distribution companies are having the wherewithal with, and some of them are actually deploying it. As we all know that on an average, our average power consumption per capita is about half of what most of the developed nations would be doing, and it is 1/7 of some countries which are European countries. So given that kind of a gap between the power consumption and the scope and the opportunity that India sees now to achieve the growth, we need electricity. And electricity, when you do it with the combination of renewable energy, which is variable in nature and intermittent in nature, you need to not only see as to how you are going to deploy the technology to do a demand forecasting, as well as ensuring that people change their behavior to use the energy when it is the cheapest. Now, given these kind of a contours whereby you want to grow, you want to inject more and more renewable energy into the grid, and would also try and minimize the cost to the consumer, as well as making sure that the demand and supply matches in a way that there is no power hunger which is left and which prevents the development of the country. It is all the more important that we deploy technology. Fortunately, to our benefit, there are multiple options. And India is considered to be the leader of providing right minds, right technology, and practically and literally we are running the world from the resources, the best human resources that we have. So this is an opportunity whereby we possibly can try and create a system, an environment, an ecosystem, whereby we can say that yes, if we have to deploy renewable energy, also to take care of our growth that we have in our mind, we can use the data, we can use the insights that technology provides us and try and balance the situation whereby we do it at the cheapest cost possible. And for that, we need to have AI/ML deployed. We need to have a lot of data crunching that we have to do. We need to create a foresight because of this data sciences and deployment of all the data that we have. And as they say that data is a new oil, so why not to do it in India? And the kind of consumer base that we have and the kind of portfolio that we manage, whether it is an agricultural consumer or an industrial consumer or a commercial consumer, this kind of a depth and the width in the system does not exist in any other country. So we could be the leaders if we try and deploy these technological innovations into ensuring that we match the demand with the kind of supply that we have. And here is an opportunity with the luminaries seated on the dais having a vast experience into these areas as to how we do it. So we have to deploy this data to ensure that the grid stability is maintained. We have to also ensure that we use the latest technology of metaverse and other things. We also have to see that we do a complete data crunching so as to ensure that we are able to forecast the demand and supply and try and match it. We also have to see that what could be the spin-off effects of it, which probably we are not able to fathom at this point of time. And maybe in the coming years, we will be having so much of a data that we can actually predict as to how the consumer behavior is going to change. So there is a huge amount of opportunity that lies before us. And I see that the kind of granular data that is going to come because of the Government of India initiative of smart meters, which gives us about 96 clock in a day, the information about each consumer, to the extent that which appliances are being used by which household or by which industry can actually be predicted, analyzed and told. And because of this analysis, we can possibly be able to actually tell what is needed to be done. And I'm sure that today when speakers speak about their experiences, they share what they are doing, there is huge amount of learning that we will probably have from each one of them. I will not take any more time, will not stand in between them. And I hope that this session is going to talk about latest technologies, whether it is AI/ML, whether it is grid technologies, whether it is new cabling methodologies, digital twins, and many more. So open to you, and I welcome the first speaker to come over. And since the panel is big, so I would sincerely request and earnestly request that everybody would have to manage the time. And if Ms. Suri refuses to do that, then I would have to intervene in between. But we have to abide by the time because after all, we all have to be disciplined in our lives. And I know that if we are disciplined in our speeches, it would be great. Thank you very much.
Thank you so much, sir. And you rightly put the question that a lot is happening. DISCOMs are struggling and also enjoying the new technology uptake. And with the changes happening and the consumer demands rising, they are really becoming demanding. We have to bring the change and adopt the new technologies. So with that, let me invite our first speaker. We have two speakers from Tata Power, Mr. Devanand P, Chief Tech Services, and Chintamani Chitnis, Head Power System Control. They'll be, Tata Power has been very actively involved in wide range of innovations that they are bringing, and we're looking forward to hear from them about the underground cabling laying, and as well as with its management with the digital twin. That's what Devanandji you will be talking about.
Yeah. Thank you, Reena.
Over to you.
Thank you, and Honorable Chair. Good afternoon, all my Power Distribution Universe colleagues. Right? Why? Because possibly this is what we are in. We are all discussing on what's going to happen in this universe and how we are going to manage it. Honestly, I would be sharing my practical experience and how we have gone from being a normal grid to a smart grid thought. Now, right from beginning, I've been always saying, when did our phone become a smartphone, right? when we had all the application integrated into it, and we could call any application when we wanted it, right? So in other words, all those which we do here, all the technologies which we talk about, all the challenges which we talk about, if we don't have an integrated way of controlling it, I think it's like running with multiple fast horses, just we don't have the reins, right? Just think of it, if you don't have a proper rein which controls these all horses, well, we will end up with something else rather than achieving something. In similar way, in case of distribution, we are going through that. We are riding on very fast horses, that is absolute greening technologies, the ones which just is not in our control, right? Whether it is solar, whether it is wind, or for that matter, EV charging, right? So all those horses we are making just seemingly are without control or limited control, right? So what we need to do is we need to find out mechanisms which need to be brought in control. And we have to remember that we are working with power system, right? The power system is something which has to be in control. Otherwise, well, we may have light now, afterward there will not be any light, and then again light. So that's not something which we require. So thinking on that way, we would be presenting two cases, one with respect to power management and another with respect to asset management. I'll just run through the thing, though I'm not going to continue with some of the, decorations which is there. I'll just go down to the key factor, right? So what we are talking is, generally we say 3 days. Yesterday we saw one more fourth D which was discussed on disaster, but fourth D is something everybody discuss in a different way. But in my context or my belief, I feel that one D is the hinge amongst all the Ds, and that's the digitalization. Because unless until there is a solid digitalization, rest all Ds will not make much of sense. It's like, again, having multiple horses, but not without a rein. So the digitalization one works as the the rein. So I'll not go to the detail of this, but then I will come to what I am talking about. So what we are discussing here is that, I think our chair presented the case that we are discussing with all the technologies. Now we are talking about AI, ML. Now let's pass on to the control room of a distribution company. You have contracted green, you have contracted renewable, all variable renewable, you got battery, you got EV coming in, you know where the loads are, you got smart meters. I think you got so much load of data which is coming, but just think of that guy who has to make a decision on that 15 minutes, right? And go ahead, 1 day ahead. Or when he is struggling, this market is not, you don't have power available in the market. How is he going to make the choice? Whether he wants to do the load shedding, what do you want to do? Now this is where the whole thing acts. And this is what our thought process, right from the day when we have started in this type of open atmosphere, is to create a platform where I can bring everything together. Now, this is what we are talking about. So this is the platform which will have all the things coming in, all the technologies coming in and interacting with each other, so that at any moment of time, you always take the optimized decision, right? So let's see what are the components of this platform. You have the forecasting module, which runs on AI ML. Of course, in Mumbai, there is another category which is known as the changeover customers, or where you are predicting something based on some other customers. These changeover customers are that content carriage, this one. That means the customers who are on X wires with Y supply. So those consumers are very difficult to forecast and manage. So there we use these technologies. Then, very importantly, the new systems which are coming in, that is the rooftop solar as well as EV charging. So that also is mapped. So in real time, the person sees what are the trends and accordingly they act on it. another part is now we talk about this RA. Guidelines have been released. Now that is on a large scale, but how do you ensure that the RA is also maintained? The resource adequacy at any moment is maintained. You are ready, what we call as a risk-based resource management, right? What is the risk of a certain thing, certain availability not being there, and what are the action plans, right? And this is one for our customers where they can actually plan their greening options by using a green tool. And this is also integrating the DR module. We already have done some DR on behavior-based DR, but now we are also planning for auto DR, which will be also helping us to manage the load as a part of it. Now this is one very unique thing which we are working as pilot, which the pilot is running. We have seen peer-to-peer trading on rooftop, or say prosumer-consumer. And this is a trading of green between open access customers. Now this is a very key part, especially when we are looking at a scenario where 100 kilowatt and above green open access. Yes, please. Sir. I think I've given that word to Reena ma'am that I'm not going to take more than 3 minutes. This is the last one, I think just before Chintamani comes in. And this is what we are now where we are talking about a autonomous bot-based power management. Using all the things which you saw, it helps my control room to actually have a complete situational awareness, and the system itself drives what needs to be done. So this is what the latest in technology what we are doing. Now I'll ask my colleague Chintamani to touch upon the cable part of it. Thank you.
Yeah, so good afternoon and thank you, Devanand. While we have been talking a lot about IT/OT part, a very important aspect that probably needs to be seen is the hardware part, which I call the HT part, or the hardware technology that we have. So this part, in terms of, in fact, the last session dwelt a lot about the underground cable system and the need to map it, not only with respect to the load part of it, but the thermal mapping of it. So I will take you through some of the modern or latest techniques that we deploy in terms of cable laying. So what we see here is a typical scenario that you see any part of the country where cables are being laid, they are being dug and they are being redug, and actually we are at loss to know where the actual cable is when we actually go to locate the cable. So what we do is that we use technology in terms of a RFID ball marker or a tracker which is actually put along the length of the cable, which actually can be programmed to tell where I am, what I am in terms of the joint, in terms of the distance. And further we map this in the geographical information system, as you can see here. That itself makes it a fit case of a digital twin of a cabling system that I have in my geographical information system, whereby I will be able to access this kind of the cable laid anywhere across the domain and make it easy for managing the assets. So I will take it further. We have talked a lot about communication technology. We have been laying power cables, we have been laying communication cables. They have been laid separately and they are still being laid separately. Whereas a prudent way of doing this is to make it a composite kind of a thing, where there have been examples in the country where we have a composite power and a fiber cable. It is a simple construction, as you can see on the leftmost part of it, where one of the fillers is replaced by an optic fiber cable. There is another method by way of which you can actually lay the fiber optic cable on the underground cable itself. So what we are trying to do is that we are using the power of optic fiber to actually assess the condition of the underground asset. So what are we trying to do? I will tell you two case studies, and they have actually been deployed in Mumbai and Delhi, the earlier one also and this one also. So as I go along, what you see on the leftmost corner is that you can actually make out any movement that is happening on the surface above the ground as to what is happening in terms of a digging happening, in terms of an intrusion happening, and I can sit back at my control room and actually know what is happening, and I can be forewarned of the cable actually getting damaged. So this is what can be deployed on an underground cable asset when you have actually a fiber optic cable being an integrated part of the cable or maybe an add-on to that also. Additionally, in the last session, Ravi sir was mentioning about the thermal mapping of the cable which we need to do. So as you see on the right, you can actually see the thermal profile of the underground cable that we have laid across to actually know whether there are any hotspots that have been developed along the length of the cable, so as to proactively take any action before any kind of failure happens. So these are two, I think, ways in which we can better manage our underground cable system, because in this transition from whatever we have to a net zero thing, we need to have a lot of power that needs to be transmitted, and in a disaster resilient situation more so in the underground part of it. Therefore, this is very imperative that we get this embedded as a part of the system. And of course, summing up, what I feel is that when we are transitioning from this kind of a situation to a net zero situation, what Devanand was referring to, digitalization is of course one area of it, but deregulation in terms of actually making this viable for all the prosumers to be a part of the ecosystem at the edge of the grid and the consumer is very important. And therefore, today we have what is called as a network operator who is actively operating. What we need to move towards is a concept of DSO, or the distribution system operator, which is operating elsewhere in the country. But that is what I had. Thanks a lot. Thank you for the time.
Thank you so much, Mr. Fitness. So a big round of applause for Tata Power. And I request our next speaker, Mr. Gopal Narya, Head Project Monitoring, BSES Rajdhani Power, to talk about the innovation that they are working with, particularly the digital twin projects being implemented at BRPL. Over to you.
Thank you, ma'am. Today I am going to talk about one of the digital twin project we are implementing under United Nations Environment Protection Fund. So basically, I am Gopal Narya. I am from BSES Rajdhani Power. Unfortunately, this is my designation you mentioned was a project monitoring. That was 10 years back. But today I am taking care of CES and automation. Apart from that, another data analytics, renewable. So this is briefly, I will cover about BSES. We are basically Delhi distribution company covering around 695 square kilometer area, 29 lakh consumer. Density and peak demand is 3457 that we face in 2022. That's actual peak, not as per the meter data. Our total billed energy is 13,149 million unit. Loss is around 1.14. The biggest surprise Khobragade sir has given us in this session was 7.69. So that was unbelievable to us. That too from any state electricity board. Now we have to learn more from you, sir. So this is something, the technology map so far we have traveled, and we are in the last present page, we are doing so many different pilots. Now that pilot is still pilot only because of our learning. Because we are the one utility, since last 20 years, we have 100% digitally downloaded meter data. The biggest challenge is how to use the data. So far, there was no tools available. But we are hopeful now. But the key learning, there are certain learning we came across while during this journey was that with so many different solutions, what we are going to create another devil. The devil is so many different silo of technology. The technology is not going to interact with each other. Second part, let's say if we talk about meter, we are using smart meters since last many years in our SCADA distribution network. The basic purpose of that meter is to know at any time what is my real demand in my network. There are around 300 feeders feeding BSES Rajdhani Power Limited, and it is very difficult for us to know at any time in a day what is my actual demand. And it is expected that before consumer realize that I am going to use power now, I am going to switch on my bulb. 24 hours before I am supposed to arrange that power very accurately. In Delhi, our responsibility, as per our responsibility, we are supposed to manage our demand within plus minus 8 megawatt out of 3,400 megawatt requirement with all these factors. So what was the learning in this smart meter was that unless we have a time synchronized data from meter, that meter never give us a valuable input except a role of billing meter. So likewise, there are so many small things that I am not going to talk, I am not going to take much time on that part. So today, I wish to share our this digital twin project. And typically, if you talk about automation availability in power sector, so in power sector, if we talk about generation, then transmission and distribution. So generation is highly technology-oriented segment. In generation, generally, the technology like DCS and some other feature is so advanced that it is much advanced than any typically aeroplane automation technology. Just like in gas turbine, the Marco technology control system was used almost 25 years before. Similarly, in distribution, we are still at a SCADA level, and that technology usage is limited to only switching on and off and some monitoring part. But the key driver for digitization, we have talked on that subject almost in all the session, was the legacy issue that we were discussing about peak and capex related issue, space availability. In my view, that's not the real true problem, basically, why we want a digital technology, digital tools. Because in Delhi, in 2002, Delhi distribution sector was privatized. Why it was privatized? Was the problem was related to financial issue? No. Government were having a lot of fund. It was power availability? No. 20,000 megawatt PPA was signed before it was privatized. The biggest bottleneck was a human capital. 1998 ensured that a major reform take place in power sector. The licensing mechanism was one of the major restrictions for new investment. In 2003, we refined the act again, and there was a massive investment flow. Unfortunately, before that investment and innovation reached to the distribution company, we stopped in between. We never calibrated our policy. What happened? Today we have enough power, surplus power, but where is the Indian business house? Almost all business house vanished, collapsed literally. Hardly few survive. And many don't have any hope to come up again. At the same time, almost all banks converted into NPA, big NPA. Why? Because all the return of all the investment was supposed to come from distribution company. And the biggest hurdle was human capital. Now, why hurdle? Because traditionally, all the work or the method adopted by any distribution utility is very, very old, is with limited information. With digitization, the biggest advantage we are going to get is that we are going to act on very accurate information. That accurate information or data will happen only if we deploy a solution very carefully and with basic requirement, with keeping in mind the learning that we have learned out of our already accepted technology.
So you have 2 minutes more.
Sorry, ma'am. So basically, technology adoption wise, so far SCADA was the one major thing that has reached up to the distribution grid level. Beyond that, medium voltage and LV was a total gap. Instead of first prioritizing that sector for digitization, we jump over to the smart meter. Now, somebody will tell, why do you want digitization in between? Because we are deploying smart meter at the edge. That will give us all information required. What is the power availability and all reliability, performance indices, metering data, and so many things. But as we said, most of the people we are talking about AI ML once we are going to have a digital data. But I want to just highlight here that before we think about AI ML, we have to think about natural intelligence available in the system. And that natural intelligence can be harnessed only we cover this dark part of medium voltage and LV part, digitization. So basically in digital twin, the basic roadmap will be a sensor level, over and above physical layer will be a sensor level, then communication, then information management, data management, functional layer, and business layer. So this will be the road. Communication is very strong today. Data analytics, lot of IT system has given lot of advantage. India is having lot of advantage in particular there. Functional level, lot of startup as well as existing technology company has provided solution. In our digital twin, basically, briefly, this project is United Nations Environment Program Fund under a grant, and Panitech is the executing agency, BSE is a DISCOM, Vinyos is a technological solution provider, TERI is a knowledge partner basically. This is the total consortium of this pilot. We have selected around 4 locations, 6 distribution transformer, 3,000 customer, and deployed high quality power meters. We call it smart box. So that's all arrangement for that pilot. Basically, we are focusing about monitoring, intelligent control, forecasting, and efficient planning. Out of these 4 segments, we have identified around 8 use cases. So grid operation analysis, feeder loss validation. So far, we have reached up to the DT level. LT feeder is being talked nowhere. So we are touching upon that LT feeder loss. Transformer operational parameter, particularly overloading, is one of that key consideration. Transformer health assessment, battery energy dispatch strategy. We are having around 1 microgrid, 6 distribution transformer level grid. We are also going to award one more 20 megawatt grid scale battery energy storage project. Very soon you are going to heard it from us. Then automated demand response use case is covered only to understand the functional requirement of ADR program. DR integration and
Mr.
grid
Nari, I
impact
would request
analysis.
you to please
Yeah, sure.
close the presentation now.
So last one is grid. So this all the very recent data set we received from our that pilot. This is all expectation. So far it's just beginning. So instead of elaborating more, I will prefer that next ISGS preferred we will share the more learning.
Absolutely.
Okay, thank you.
Thank you so much for sharing this results of the pilot, that we have more time to interact on this. And I'll request all the participants who are keen to learn can connect with Mr. Naria directly. So I would like to now, with that, invite Mr. Preetham Mupuri. He's the Business Development Manager with Amazon Web Services India. So Preetham, what are we going to talk about? There's a lot of innovation that AWS is working with. Yeah, over to you.
Thank you, everybody. Thank you, sir, and thank you, the other panelists. Good afternoon, everybody. I'm just going to cover 3 aspects. Why AML, how to run AML in utilities, and where, a few use cases where AML can come handy in utilities. Now, why AML is something which I think the time has come. Nobody can stop that force. All of us, especially after ChatGPT, everybody has used it, are a part of it, because the data which we give is also part of AI/ML. So we are all part of that universe, and this is irreversible. But just to bring some numbers to the context, as per IDC, 40% of digital transformation initiatives in 2023 will be centered around AI/ML. It's the heart of everything, and it's going to touch all aspects of any company, whether it is utility or otherwise. Operations, decision-making, finance, innovation, everything, right? Now, why AML matters? This is how we were doing. I mean, getting information from data was nothing new. It was always happening. But we were doing it sort of manually. Just to take a simple example, if you want to find anomalous data in metering, in metadata, earlier we used to define what an anomaly is, and we used to code if and else statements and then get anomalous data. A very simple process. But then that had issue of human bias coming into the picture, and at the same time, it was time consuming to code when you go into complex use cases. So what AML does is it automates this process where the machine, looking just at the data, will understand the patterns. It will define the anomaly by itself. You don't have to do it, and then give anomalous data. That way, we'll be looking at data in a much different way, in ways where humans couldn't comprehend in the past, right? And the financial impact of it is, again, by McKinsey, the data is that automated inspection, preventive maintenance, and demand management in utilities can raise EBITDA by 20 to 30%, and in India, it's going to be even more critical. Now, how to run? I will not get into the details because it's a little more technical. But before you run AI/ML models or run analytics, the most important part is to get the data into one common place, which is data lake. You need to connect and bring different data sources into one common place and then run analytics on top of it. So these are the few. I mean, all of us are aware of these data sources, and then run models. And cloud is the best place to do that. I will talk about why it is the best place to do that. So this is just a snapshot of what all you can do and how cloud helps you bring the data into one common data lake and run models, right? So cloud provides tools for ingesting the data from the data sources. It provides tools for transforming the data and loading the data, correcting the data, creation of, manage the data lake, which can run into hundreds of TB. The scale is unprecedented with smart meters coming in right now. And on top of that, there are a lot of custom models which are available on the cloud, where you can leverage those models and go up and running within a matter of days, instead of hiring large data science teams. So that is the advantage of cloud, and this slide just reflects that. Now, way to leverage, you're all domain experts, so you'll know better than me way to leverage AML in power. But talking about net zero, renewables and DER is the obvious place to start with. Renewables by definition are unpredictable. So to bring in that prediction, machine can do it much better than humans. So that is one area. Customer engagement, where customer churn may be important going forward, given content carriage separation, like my colleagues from Tata Power were talking about. In that context, again, giving personal insights to customers and helping them with their energy efficiency targets is going to help retain the customers in the longer run. Then asset planning, predictive maintenance, reduced downtime, better performance, asset performance, better return on asset. All these things can be done with crunching of the data in a much better way. Revenue protection, all of us know. Then, reduce outages, predict outages or predict equipment failure, send crews in advance so that you reduce the outages. These are a few common areas where we will see a lot of adoption of AI/ML. And just to give you an example of customer engagement, recently we have demonstrated a small use case to a large utility in North America, where we put the power in the hands of consumers who were doing EV charging, and we were giving all the data that they need to make the decision when to charge, right? So if somebody was plugging in at 7 a.m., we were able to tell them that, you hold on for another 2 hours. There is a chance that the sun can come out and you will be using more renewables. Right now you will be using 90% fossil fuel. If you wait for another 2 hours, you will be using 50% renewable and 50% fossil. And that way, I mean, you are going to be also contributing to the DR program, and probably you are going to be incentivized to this extent. So that behavioral change is something which can be done with AIML. Again, I won't go through all of this. Just wanted to touch on 2 or 3 aspects since other panelists have talked about load forecasting with tools available on cloud, where you don't have to write models or you don't have to have big data science teams. Cloud providers provide services which can take the data, iterate on the models, tell which model best fits, and then gives you the accurate forecast. Example, we have done a project with one of the large power exchanges in India, where using Amazon Forecast, which is a forecast tool available with AWS, we were able to get about 98% prediction accuracy in intraday and about 95% with day ahead. Similarly, on computer vision or computer recognition, we have done a case where OCR was not very accurate on meter reading, that we all knew. But with AIML and understanding and computer vision, we were able to accurately process the meter image, not just for the numbers, but also whether the meter was a direct meter image or it's a photo of photo, or whether there is any fraud involved in the act of taking meter image. So these were a few cases which were done with AIML. With this, this is going to be my last slide. And so a few popular services from AWS. Amazon Monitron is an end-to-end ML service for predicting machine failures. This is a combination of field sensors plus data concentrated devices plus the data tools on AWS cloud. So it's an end-to-end package, and it is used in most industries, including Amazon's own fulfillment centers, etc. Now, when you already have sensors in place, like in most of the power sector sensors are already in place, then in that case you don't need to go for Monitron. You can simply take Amazon Lookout for equipment, which is a AWS service where you get the data which you already have on premises into the cloud, and then there are pre-built algorithms which will help you detect abnormal machine behaviors. Then forecast is something which I talked about. It can help you forecast anything and everything without having to write the models. Then recognition is an image or computer vision based thing. All right, case studies. I'm sorry, do I have time or?
Just 1 minute.
Yeah, all right. Just to give the scale of AIML that is happening on the cloud, about 10,000 plus customers are running their AIML projects on AWS. About 81% of deep learning, including now with GenAI, etc. 81% of deep learning happens on AWS. 85% of TensorFlow projects, which is again a model for AIML, happens on AWS. And yeah. So this is one of the case studies where PSC utility did forecasting using Amazon Forecast. And with this, I'll conclude, and I'll be happy to take any questions later on.
Thank you so much, Preetham, for adhering to the time and sharing how these technologies can help better prevention, optimization, and better management of the utility processes. So thank you for sharing that. Now I would request our next speaker, Mr. Manish Patel, Senior General Manager, Business Development from Apar Industries Limited. Over to you.
Good afternoon, everybody, and thank you, ISGF, for giving us the platform to speak regarding some new technologies. And technology was first, I was going to talk about to you regarding the covered conductors, which is not new to any of the utilities right now. And it is being there in the utilities for some time now. And we have seen some challenges. So we just go one by one on that. It's not moving? Okay. So the concept behind the covered conductor, because there are the many challenges regarding the bare conductors. So utilities started, using the covered conductors, and those challenges are commonly by all the utilities are like the clashing of the conductors, then the slashing of the conductors due to corrosion, then some temporary tree contact transient faults are coming in that, and corrosion of joints right of the way. So all these challenges are being addressed by the covered conductor over the line, and it is found to be a very useful tool to the utilities right now, to that they can use that. But still, when they are started using this, then the new challenges have come. Those challenges after using the covered conductors is like they don't know whether the span of the poles are higher or lesser. So if it is a higher and you are using a AAAC conductor over there, then there is issues on the insulation, the strength of the insulation and the conductor versus the weight, because the conductor is bearing almost double the weight of the insulation over it. So in the higher spans, it goes down, it will snap. Then losses increases. Then if you are using the AAAC ACSR, which is right now they are using, so what we are feeding is inside it that like all the heat which is get trapped in the insulation so because of that heat trapping, the heat dissipation becomes slow, and if it is slow, then the resistance little bit increase, and that contributes to the losses. So around 2 to 3% losses are there in comparison of bare conductor what we are using it. So then the temperature limitations are there, because you cannot, the XLP sheathing which is used on the covered conductors, that is the only solution right now, and in the cables also the XLP is going to be used. It is like 90-95 degrees centigrade. So that limitation, but the conductor limitations is what? I'll come out with that conductor limitations on that. Then the degradation of the operational life of the conductor with the wrong installations, because this is a system. Covered conductor is a system. It is not like you are selling just a line or a wire over there. It is an entire system which is going to be there in your system network for more than 40 years. So the wrong installation will degrade its life. Then it is all. Many places we have seen that the utilities, yes, they are taking the material in a very good quality, but the accessories used by the EPCs, they are not of the standards, and it has to be follow those standards which is being used for the covered conductors. Page down. Okay. So if we see that what we are using right now is a AAAC and ACSR, these challenges are already there. To meet out those challenges, the new conductors we can do, because on the insulation side we cannot go much beyond, because there is a temperature constant. No polymer can sustain for a very high temperature on the conductor. Conductor may go with the high temperature, operating temperature, but insulation has their own limitations. So within those limitations of the insulations, what we can do is we can go for the conductor which can give us a better conductivity. So for that, there are the new technologies available, which is AL59 ACS, where and the ACSS, where there is temperature and the insulation both are being handled. In this AL59, it is handling the, right now what the XLP limitations are there. But beyond those XLP limitations, then ACSS, ACS are handling. That is gone up to the temperature withstand up to 120 degrees centigrade. So these are some new conductors. So I'll focus on the AL59 ACS right now. This is all the coverings. It has triple excluded layers. One is the semiconducting layer, then the pure XLP, and then the XLP, which is the outer layer. This outer layer is having the UV resistance and all the anti-track properties over it. But in the conductor, now like you can say this AL59 ACS is the extended part of the ACSR. So like that, there is a steel wire, and over the steel wire there is a aluminum cladded steel, aluminum cladding. So this aluminum cladding is also giving a conductivity, and the strands are of AL59, which is the best alloy available right now in the category of alloys, that is AL59. So the conductivity is 59% over in there. So it gives you a more current carrying capacity, less losses, and high temperature withstand. So if you can see one of the technical comparison in this, I am not going through all, but a little bit. The current carrying capacity, if you are getting at the ambient temperature of 40, the temperature resistance here in ACSR is 75 degree only, the limitations. Here it is in the AAAC, it is only 80 degrees centigrades. But in the case of the AL59 ACS, it is 90 to 95 degrees centigrades. So here you are getting obviously more current, 30% more current carrying capacity. Then the braking strength is also increased drastically in this. And the DC resistance lower the losses. So moreover, with these technologies, if you can take a payback calculations, how the utilities are benefited out of it. And if we can take the example of if you are using the ACSR dog, so if we take it 0, then the additional revenue generation in rupees per kilometer per annum. In case of the AAAC, it is minus 5.18 lakhs. And in case of the AL59 ACS, it is plus 71,000. So that gives a big revenue to the utility if they are changing it from the conventional conductors to the better conductors which are there to serve them. This is all governed by the SENELEC standards. That is all EN standards. And here the covered conductor as a technology, it needs to be followed with the 50397 part 1. And the accessories should be at the part 2. And the installation methods, which is very important, which is not taken care by the utilities right now, it is covered under the part 3. So I'm not covering all these tests because it is on the conductors and the coverings. So it's all maintenance-free technology which will be used. Minimal maintenance is required annually to just have a ROW. No tree branches touching continuously on the covered conductor. And in the event of any snapping, it can be joined very fast. The advantage basically is the lower operational and maintenance cost, cheaper in life cycle cost, then higher mechanical strength compared to the AAAC and ACSR, then better corrosion resistance because it is a ACS steel wire which is protected by a thick EC grade aluminum covering. So the corrosion chances are not there, and it has a very good use on the sites which is near to the sea sites. The salinity area is there, so then it can be used properly over there. Then AL59 is operating temperature can be gone up to 95 degrees centigrade with the same sag and the performance. Then low working tension, that is very important on the poles because these poles are very old. Whatever you are replacing your bare conductor with the covered conductor, the poles are old. So they should not possess the more tension over it at the tension side. So in this case, the tension is less compared to the AAAC and ACSR. And the lower the power, the losses, and higher power transfer capacity.
I request Mr. Patel to please close
all,
on time.
or
yes.
I have it on some more time?
No, sir, you've exceeded the time.
Okay, just give me a moment. The accessories are all same, which is being by existing covered conductors in here. And all, thank you very much on this. And if you have any questions, I am here to answer.
Thank you so much, Mr. Patel. I hope we still have time in the end for really take it up. So thank you for sharing this wonderful technology, which will help reduce the maintenance and operation cost and further help the utilities reduce their losses. So with that, let's move on to our next speaker. I would like to invite, we have two speakers from L&T PTT Digital Energy Solutions. They are our partners for this session. I would invite Mr. Sunil Kumar, Head of Business Segment, IASEA, and Mr. S.K. Senapati, Head Sales and Commercial Services, to please take over. Yeah.
Good afternoon. My name is Sunil Singh. I'm heading the digital business of L&T for India and Southeast Asia. And Senapati is my colleague. So we just want to cover we are moving around like using the AI ML. So actually industry is changing. Like actually we work in industry more than 30 years. And we find that there are a lot of change in industry and there are a lot of regulations started. Okay, so if the utility has to run in the same pace, they have to change. So challenges, what the challenges they are facing, they are facing a lot of challenges, like definitely like effectiveness, or maybe we can say in the same pace if we want to work, there are a lot of manpower resources crunches are there. We have done a lot of projects in power grid also, in the transmission sector also. We find that even the power grid also doesn't have a proper manpower to manage the transmission grid and all those things. So definitely we have to adopt some technology so that we can also move in the same pace. Okay. So the only part I can say that the first is digital transformation. Like digital transformation is not a unique subject or a new subject, but there is a more on the integration of the whatever the technology we are using. So we are using that the same way. But the one more thing I can just add is the more on the disruption. So disruption I'm just adding because suppose I'm using a technology, like suppose I'm using a earlier maintenance of transformer. I'm just giving an example. If maintenance of transformer, whatever we are doing, suppose we get the data proper timely. Like I'm just giving an example of distribution transformer. We have done one project, small project in UP. So we find that if proper maintenance we can do, at least we can reduce more than 10%. More than 10%. I'm not giving a more figure, but that is a figure actually we are taken. Definitely small maintenance, and that maintenance required not a regular maintenance, but is more on the preventive maintenance. So for that also we require the data. Okay. So that is the one part. So my contest basically I just want to put the 2 points. First is how to use the technology, like maybe in the distribution utility, because all the distribution utility are there, so we can use some technology. And I'm not giving a very lengthy or very some vast things, in simple things, because distribution transformer, we find that in distribution utility is the most critical component, and if we can maintain properly, or if we can suggest some good technology with the low cost solution, definitely every utility can adopt. And where we can fit that, that is more on using the IoT solution. So in fact, when we do the testing, we are using the IoT solution, and we are taking the data, and the data is coming from transformer, one of the transformer, I can say that. We take the data, not wired data, I'm putting the sensor, and the sensor is communicating on the Bluetooth, okay? And the device is I'm putting somewhere else, and then we collect the data and send the data on cloud using MQTT protocol. So and the low-cost solution is there. We are using the battery for the sensor, so we do not require the wiring also. And that one of the we can say project we have done, and we find that even the small cost we can save a lot for especially for the maintenance of distribution transformer. Second part I'm giving because a lot of driven by AI and ML, but definitely some of the value addition we can do in the distribution utility, especially we find that many utility they are doing the smart grid solution, okay, like ADMS and all the things, but they are missing the field force automation. So if we can add field force automation also in that part, so that could be a good solution, because we find that whenever we do the maintenance, we don't have a time. Suppose I'm just giving an example, because we are doing a project in BST, Mumbai. We find that they have adopted the field force automation, and there are a lot of other utilities they don't have. So whenever we find a fault, based on the system can give the advice, and because already mapping the data on the GIS, so we can give the advice to the operator or the maintenance staff, which is the best way to go there and to reduce so that actual time is reduced. So that is also a major cost. If you can reduce the time and reduce the manpower effort, definitely you can reduce the carbon emission part. So this is one case which we have used in UP. This is also data analytics, where actually we have done two tests. One, we are putting the sensor, take the data, and second is based on the DT loading pattern, we have to find out which is the cluster area where we have to focus. So that is basically, we can say that this is called customer mapping. So that is the one area which we have done, and then based on the data we can advise whether we have to push, like which of transformer is there, what is the rating. So based on that, there's some experiment I was also done. And the second part is FFA. So that is also one of the solutions which we have using for BST project. So that also help in the main thing. So takeaway is the first takeaway from the DT is definitely that improve the reliability and the availability. And the second is reduction is downtime and improvement in operational efficiency. So these two things I just want to add. Yeah, go ahead.
Good afternoon. So the session is like new innovations for net zero. So I'll go to that only first. What are the disruptions, innovations which helping this energy transition, net zero power? So when I see, we are doing this much renewable, storage, when I'm talking about whatever digitalization, no, that is cross-cutting. Cross-cutting is what? You don't want to discuss or what? So the challenge is there. How that helping? So I'll touch few things which we have already done, we are doing. So one thing is that today the solar plants is going to 1 gigawatt, 2 gigawatt, 5 gigawatt. So where is the control system for that? So same PLC. So I'm not saying PLC is right or wrong, but things are changing. So we have deployed few things with edge technology and with software defined solution. So it's like a industrial PC, deploy your software on that and start getting into. Why this edge technology is required? Because the control systems, the plants have become very complex. You require very faster processing speed for that. So you require that. So we have deployed few of the things in power plant controller, in storage controller, in hybrid controller. So name it a few. Just to touch those critical things. One thing was that EV. Yesterday we were discussing EV infra and all. So we have a solution like site hybrid energy infra, and we did first POC in India, but deployed first in Philadelphia under DOE, because we didn't get nobody is there. People have seen that. Okay, we wait for some time. But those are the technologies. It manages your grid, it manages your EV, it manages your solar storage, all the ecosystem, and it takes care of your grid stability. So those are the things we are deploying. Today, third thing is just trying to touch is virtual control. Today, everything we are talking, okay, same relay-based solution and all. So we are trying to get into a pilot, means we are doing a pilot on the virtual substation where all the protection control is being done centrally by software. So even America has not done yet. Okay. So that is one thing. And some of the customers who have deployed virtual power plants in Gujarat. So the customer encouraged us to do that. So I always say, customer is the king. So they have to encourage. So I am there to do, but where is the facilitation? So those things has to happen. So Gujarat we have deployed, and that's the first time in the world a power plant controller deployed. In a single machine, there are 6 controllers, single industrial PC. So those sort of complex solutions we have deployed, and it already is commissioned. So these are the few areas I wanted to touch. And one more thing is that interoperability. We have done a substation in my Chennai campus with 5 different makes of merging unit and relay interoperability. So our last, I think, few years, we are all talking about legacy system, this, that, all fine. We have now coming out of legacy system. We have demonstrated interoperability. We are offering interoperability to our customers, utility. But the challenge that customers are also still back foot. They say, I'm happy with my same make of software and same make of PLC or same make of software with same make of RTU. And what is the fun of having this interoperability? You had a problem. We came out with a solution. So please deploy that. Encourage the industry. So that's my suggestion to the utilities, government sector, to try some pilot. Then I am not telling that I have some solution, you blindly adopt it. You do a POC, test it, and adopt it. So these are the few things just I want to say here. And today I think most of the utilities, another thing is that AI/ML. So when you are talking, everybody's there, we have a big thing. But how you can today, I think in MP, I think we have given some demonstrations there under USAID thing. So like theft detection, how we are doing using AI/ML for a theft detection. So those solutions also we are having. And energy analytics, advanced and predictive and prescriptive analytics, which our team is here today. So they can also, we can have if any queries, we can interact. And one more thing also, we have something called net zero grid interactive building, some solution. So the building management system, the chiller management, the storage, all together, we call it something called E3MS. So we can put it together and we can give. And it is giving a lot of benefit as far as efficiency, managing your workforce, and reducing your energy consumption. So that way. And we have something called net zero carbon monitoring, and the dashboard, those things also we are into. So these are the few things I felt I should share. Some of the things, first time I was saying interoperability of 5 megs, that's the first time in the world we got an award from IEEE. And I think I request all the utilities to adopt those sort of things, come out of your legacy. We are there to help you for all the interoperability things. You don't need to depend on me. So you run your own systems. You don't need to depend on any OEM also. So my suggestion is that, so try it. We can do a pilot together based on a requirement, and we can get going. So these are the few disruptive things, first of its kind, new, and is helping the utility. I think that we should work together.
Thank you. Thank you so much, Mr. Kumar and Mr. Senapati, for sharing about the AI/ML use cases and the cutting-edge technologies that L&T is bringing, and will definitely encourage all the utilities to look into that and work with you. So now we still have 3 more speakers with us. I would now go over to Ms. Meenakshi Vashisht. She's the co-founder and CEO of Tech Uncorked. They're also our exhibitors. And over to you, Ms. Vashisht, to talk about the solutions you are bringing.
Thank you, Reena ji. Thank you, Sanjay ji. I think, and I'd like to also thank ISGF for this opportunity. So 2 days and people on the dais and all the several, sessions that we've been hearing, I don't think I can teach anybody anything about the grid. And I'm an outsider for the grid. Okay, so, but you all have several years and several decades of experience. What I bring in is a few decades, and my team brings in is a few decades of experience building intelligent devices, networks, and enterprise-level softwares. And that's what we have done. We have worked very, very closely with some of the utilities here. Some of them are already here in the room, to build solutions and talk and really drive certain changes. There are early days, but drive changes in terms of driving up the grid efficiency, resiliency, and net zero transition. So let's talk about net zero. We have been in scenarios where we said, some level of emissions, we reduce certain emissions, and we make an impact. So we have tick marked, we have done climate action. However, with all this focus heavily driving towards climate action, towards the countries, towards each and every sector, we cannot just do those check boxing now. We have to move away from that, and there is a huge pressure which is coming in to do large-scale transformations, reconfigurations, or bring in technology and realign a lot of the way we do things, which are keeping climate in mind, which are basically saying, hey, we have taken real solid steps which are going to be driving changes and substantiate the climate action. So there's an interesting thing. Whenever we are talking about today about net zero, we are saying let's move away from fuel-based and move towards all things electric. EVs are the flavor of the day. We are talking about renewable energy. We are talking even in the building level, move away from anything that uses fuel. You move away from DGs and so on and so forth. So that is bringing up a very, very interesting carbon conundrum. So let's look at India itself. So India's demand for electricity is continually surging. Okay, this growing demand comes at a cost. So if you really look at the carbon emissions, almost half of the carbon emissions of the country are coming out from the electricity. Okay, the electricity generation, the way we are distributing electricity, the way we are, so anything which is related to electricity. And on the other hand, we are saying net zero means reduce fuel, move to everything electric. So what we are doing in this process is we are increasing the stress on our grid. Okay, on the generation, on the transmission, as well as distribution. Okay, so something which was already contributing almost 50% of the emissions, and now I'm putting more pressure on that. So, this is an interesting conundrum which is coming in. The harsh reality is that we are talking a lot about renewable energy, a lot of investments are being made, but today renewable is not really replacing anything which is fuel-led. It is on top of it. First of all, world level, global level, we are just talking 14% is renewable. Rest is all, coal-based or, any specific fuel-based technologies which are used for generating electricity. And the electricity demand is continuously increasing. Okay, so somehow what it means is there needs to be a strong drive which reduces our consumption and enhances our grids. Okay, so anything which is being lost in the grid, we need to minimize those losses so that what we are generating, almost in an ideal world, almost 100% of it can be given out to the consumers. And similarly, at the consumer level, at the building level, there have to be reduction in terms of consumption so that there is some level of balancing act can happen, and really a net zero world can really be a reality. It's beyond the papers, outside those conferences, but it turns into a reality. So, yeah, I know I may touch certain nerves here, but yes, we're talking about a very big country. Okay, we're talking about a country which is more than 3 million square kilometers. Almost every 1 square kilometer, we have a grid access point. And while there are pockets of smartness, there is a lot of work everybody's been doing. Let's face it, it is a vast country. It's a huge grid. And, it is vulnerable. We have issues in terms of being able to forecast breakdowns. It takes us time to isolate faults, manage demand efficiently, and ensure that there is a consistent and high quality power. So what definitely everybody's been talking about is that we need the grid to be smart. But now, with all this thing where everything is moving towards electricity, it is not a nice to have anymore. Because let's consider a world where all your vehicles are electric vehicles. They need charging points. You cannot live with outages. You cannot live with unreliable electricity sources at those charging points, because things will come at a standstill. Your traffic will come at a standstill. The buildings and the homes we live in will come at a standstill. So it becomes, from a nice to have, it is mandatory, it's critical to make sure that the grids are really reliable, they're high performance, and outages and power quality issues are a thing of the past. So grid digitization, I think, plays an important role. I will not go into everything here, but yeah, essentially it is all about capturing data, analyze and correlation of that data, identification of bottlenecks, grid anomaly, and then build that prescriptiveness in. So it's something which comes as a hindsight, which is, here is a lot of data to look at. It needs to transform into insight, and then foresight is where you say, hey, I'm able to predict what's going to happen, so let me take actions early on so that at the consumer end, we do not see a blip in our grids. Okay, so I'm just very quickly going to talk, it's a vast this thing, but I'm just going to share a few slides of one of the work that we did where we digitized the LT distribution grid, which comprised of distribution transformer, ACBs, protection relays, and RMUs. More than 100 sites were covered in this. And the aim, the entire objective was that can we have AI and IoT, which can basically build a proof of concept, kind of a small proof of concept where we say, okay, can they make the grid smart and predictive? And it needed to satisfy 3 key tenets, that we should be able to auto-detect anything which is happening on the ground, trigger actions, real actions which are based on predictions, which are based on analysis, to trigger healing, and then the auto maintenance part of it that in the long run continue to maintain so that we can just give just-in-time maintenance calls. And if you look at it, this is how the platform was deployed. We had IoT devices sitting at the grid access points, capturing data, taking all this data to a large, big data tech stack and an AI engine, and then trigger various healing triggers. So this is just of how it looked like on a side. Just here and now, I'll just skip it. So this is an interesting slide. So as we started getting the data, what we found was here was a grid where if you look at the aggregated phase metering, everything looked pretty balanced. But the moment you went to the feeder level, we found that at the feeder level there were balances and there was something which needs to be done. Okay, and the AI models basically work, they love this kind of data. And they worked on this data and said, hey, I'm sending you an alert that continuously I'm seeing an unbalance on these particular feeders. Here, this needs some kind of a load redistribution, and so on and so forth. So huge amount of data coming in, and then rather than fancy dashboards saying, okay, this is what I'm, right? Of course, the fancy dashboards were there, but then real actionable alerts which went out, which, this is another example that looking at bushing temperature and oil temperature, and suddenly the frequency of that cooling and heating up changes. Here the circles indicate that, and you suddenly find that, okay, there is a big change. So the actionable alerts go out either in form of real alerts to the people on the field, or they go out as automation triggers, where you say, hey, I'm going to trip a particular breaker, or I'm going to enable a switch gear, and so on and so forth. And so the benefits to the utility, I think, as I said, early days, with more than 100 sites, it's a data which looks good, but then if you're looking at a grid at large, lot more work needs to be done. But I think the early indicators is if we do digitization, it definitely improves the quality of the grid. It improves the reliability, the power quality. It gives us a tool to flexibly and very effectively manage the grid assets, do asset lifecycle planning, and it also gives us some amazing insights for future investments. That's it from me. Thank you so much for listening to me. Yeah.
Wonderful. Thank you, Meenakshi, for absolutely keeping the time, and as well as sharing the innovative cases and the technology you're bringing. So I'm sure there are a lot of questions, and I hope we find time to pose them to you. So we have two more speakers. Our last second speaker for today is Mr. Vetrivel Kupuswamy, Senior General Manager with Schneider Electric. I hope I spelled your name right, yeah? Okay. Thank you, and over to you for sharing the digital substation experience and cases.
Yeah, thank you.
That's right. Over to you.
Good afternoon, everyone. I think the previous, my fellow speakers made my job easier. Most of the topics, what I want to cover, has been partially covered by the fellow speakers. So I would say right now we are in a critical juncture where we can actually co-create the future. Some of the trends we are talking about, the more electric, everything is turning electric nowadays, like it's growing at 2x faster than what we are expecting now. Plus, my fellow speakers talked about 3D, digitization, decarbonization, and decentralization. This is an opportunity where actually we can try to change the future. One of it is like digitization. Everything is getting digitized with IoT coming in. More and more devices are getting connected in the digital world. Similarly, the decarbonization. Almost 82% of the current buildings across the world, there is a potential to increase the energy efficiency. Means there is a possibility to decarbonize. Similarly, all the new capacity additions, 70% of it in India as well as globally are going to be renewable. And the other challenges the power industry is facing, most of the users have spoken about it. The network reinforcement which are required due to the distributed energy generation, plus the EV coming in, because no more it is a centralized system where the power flows from the generation, then stepped up to transmission and then distributed. With the availability of DERs, distributed energy resources, anyone can generate. It is now no more a consumer. People are talking about prosumers. So a consumer can become a producer as well. So there is always now it is becoming more of a bi-directional flow. So it creates a lot of complexity in the network. Second is the TOTEX. Earlier people were talking about CapEx. It's no more just CapEx. It's CapEx plus OpEx together. That is what now more and more users are worried, because the trained resources are either on the verge of retirement or moving out. So the availability of technical pool is getting smaller and smaller. The third one, we already spoke about, the network instability. As well, now both earlier transmission and distribution systems were not talking much. With more digitization, there is always now both-way communication is happening between the transmission and distribution systems. With more renewable coming in, the grid codes are evolving every day. These are some of the challenges. Plus, with the digitization coming in, there is what do we do with the data? Because there is terabytes of data which are flowing in from each of the primary assets, electrical assets, into the central SCADA and other places. What do we do with the asset, and can we infer something out of this data? Plus, with more and more digitization coming in, the other worrying factor from the end user, the power industry is, am I prone to cyber attack? We have already seen in multiple places where the systems are prone to cyber attack and then the hackings are happening at the various places. So these are some of the trends I already discussed about it, so let me skip. So if you look at the Schneider, the system what we are offering, we covered as we spoke about what do we do with data, we have come out with the apps and analytics layer, where we have using the artificial intelligence and ML, we have built our own advisory layers available, with which we can actually provide the consultancy services, advisory support to all the end users across various domains. And one of the solutions which, as we spoke about the various challenges previously, one of the solutions which I'm going to propose is the digital substations. Because the substation is a critical node in a part of the complete grid. So we are making the substations more digital by removing the conventional systems with digital solutions. Once we make it digital, it becomes more intelligent and connected actually. Plus, we are not only talking about integrating only the current and voltage into the system. We are talking about putting new sensors both at the transformer level, also at the breaker level, all the electrical assets, so that we can not only sense the real-time data, we can also predict how these systems are going to behave in future. Plus, my fellow speakers spoke about IEDs. Now more and more new technologies are coming in, wherein the IEDs, the protection relays, are going to be in a box. Means irrespective of application, you can use a box and you put the app, whatever protection you need, you load that app, then it becomes a transformer protection relay or line protection relay. The last one is the reliability. See, most of the places, one of the key factor everyone asking is, what is the reliability if I move digital? With analog, with the traditional wiring, the people know I can virtually see the cable and then I rely on it. Whereas if it is digital, I don't see anything. What if something happens bad? So what we are providing is we can actually increase the reliability and availability of the system by increasing the redundancy so that the overall system reliability can improve. So if you look at the left side of it, the conventional wired substations in the 90s, where the first level, like the 1990s, when the static relays came in, replacing all the electromechanical relays, and from there the systems were getting connected to the load dispatch center or ADMS system. By the evolution, by 2005, thanks to 650, we have the complete Ethernet-based, the bay level, we have bay level and station level, we have digitized, and which were open and on an open protocol. Now in 2020 onwards, the technology is maturing, wherein at the process level, we are actually digitizing all the electrical assets by putting the merging units and the switchyard itself, and then digitizing it and then sending the data over the process bus, 650 process bus technology to the bay level devices. This is an in detail overview wherein we can see actually the open architecture, wherein we can have standalone merging units or non-conventional instrumentation devices like optical CT, PTs, or in case the conventional system there is no provision. Say we are looking at the older substations where there is no possibility of putting those merging units and all. We can have just the remote IO box and then digitize it digitize all the breakers and isolators and communicate the data on process bus. As well, if there are LT and HT switch gears, those also can be digitized at the switch gear level and then send the data at the station level. So with this, we are merging the 650 station bus and process bus together and giving one composite offer. Plus the other evolutions, as I said, one is on the protection as a box. This is right now at the lab level, wherein we are all the OEMs are experimenting, trying to see can the standalone devices can be replaced with a computer, and by loading the applications, because anyway the data is digitized at the merging unit, Data is coming on the Ethernet, so it can any device, a computer can actually process the data and then do the necessary protection. That is one. Plus, we are also providing a cybersecurity block here, since as we spoke earlier, since everything is getting digitized and the data is going out to the utility through telecom, so there is a need to have cybersecurity block to protect the data. Plus the other things which are now coming up in the other areas are like APM, asset performance monitoring, wherein we can predict the future of our electrical assets. The other one which is coming out prominently is the digital twin. I think my fellow speaker spoke earlier. From the substation level, what we are doing the digital twin technology is, when we built in the design phase, we use various tools to do the load forecasting, short circuit study and all those. But when we build, we don't really check whether whatever I designed is being built or not. That is not getting transferred. So with our digital twin technology, with combining the ETAP strengths, we are actually taking that design twin into the database, into the software, SCADA software, wherein the same can be used for operating phase, wherein the operator trainings simulators can be provided, either through for training the operators, or we can do power simulation, say in case you want to if somebody has to do manually switching a particular, say opening a breaker or closing a breaker, we can run a simulation in parallel through the digital twin technology and predict whether the system is going to be stable or not before deciding the operations. So some of the key factors, the safety and security, as I said, Schneider being 100 years old OEM, the technology provider in the protection relays, we are continuing the legacy, ensuring the resilience of the system as well as protecting the data. And all the systems, what we are prescribing is as per the IEC 62443 standards. As well on the efficiency part, as I said, this is an open standard. We can actually do a lot of now with this open tech protocol, we can actually reduce the footprint of the panels in the control room. Instead of having dedicated bay level panels, this can be optimized, say 2 panels two bays, 1 panel, or 3 bays, 1 panel is possible. Similarly, we are talking about the reliability, as I said, with redundancy architecture. This system can be, any single point in failure can be addressed with redundancy protocol. These are some of the use cases wherein, what if a cyber attack comes, how do I ensure my system?
Kupaswamy, sorry, your time is up.
Sure. Okay. Thank you.
Thank you so much, Mr. Kupaswamy, and sorry for interrupting you in between, but we're running short of time. So thank you for sharing the solutions for digitalization, digital substations that Schneider has, and I'm sure our utilities will connect with you on that. So with that, we come to our last speaker, Mr. Rahul Sethi. He's the founder of Metaverse 911, and he's going to share his use cases around the potential of extended reality in the power and utilities sector.
Thank you, Ms. Suri. Thank you very much. Sir, it's a pleasure to see you here. Though I've met with you only once. Thank you, everybody on the panel. I've saved a few seconds to give you a quick introduction. I thought I'll pick up this mic from my table. How many of you are carrying your phone today? Everybody?
All of us.
This is your new phone 5 years later. I'm not joking. I've been calling, and I have my colleague here, Chirag, and we'll actually use this and show it to you right here. To start with, I have a presentation here, because I'm going to play 1 or 2 videos here for you, and I'll make it very visual. You can ask me a question. Let's get started. Like everybody knows, my name is Rahul, and I work in assisted reality all the way from mixed augmented virtual reality, build use cases and development and many more things for clients all across the world.
Introducing Plutoman 2.0, a reloaded version of Plutoman. With 8+ years of expertise in creating AR-based solutions for industrial enterprises, we empower their frontline capacities through self-assisting resources, digitize workflow, and enable efficient remote collaboration for extending their capabilities. improving their productivity, reducing operational costs, and maximizing revenue growth while promoting sustainability and worker safety. Our products include Plutomen Connect, a remote assistance and collaboration platform that features one-click connect with experts and 3D annotation of live videos for augmenting the workforce. It enables remote expert help for quick troubleshooting, options to record and save video, and a secure messaging corner. Plutomen Workflow, a work assistance platform for accessing digital work instructions that streamline workforce knowledge. It comprises task checklists, work SOPs, and lets you design effective audits and inspections modules. Plutomen Assist, a self-assistance platform for next-gen workforce training, digitalization of the process, and providing an interactive knowledge repository. It features shared resources, step-by-step guides, and interactive manuals. We seamlessly integrate our solutions onto your existing enterprise systems and custom-built features to assist you to achieve digitalization faster and better. Looking forward to partnering with you in your digitalization journey.
Incredible. So I worked very closely on building this product, and over the last about a year and a half, from the time I last came to the same session in Delhi, from then I've been working on it. So what I'm doing is, and I'll request Chirag, because I can't wear two headgear, so I'm requesting Chirag to wear the real wear, and if you can just come and stand there for people to see how it works. Yes, please, Chirag. You can just wear it, and so everybody knows. And there is a mic over there for you, because I'll ask you a few questions. Since we are unable to cast it here, that's why I know what's really going on between my screen and his screen, because we are both connected, okay? So very quickly, check. On. Save time, save money. See?
Perfect.
Come. Okay. So, in simple Hindi terms, what I'm essentially saying is, आपके जो field worker हैं, जो लोग tower पे. So I kind of say like this.
Rahul, can I just give you a quick one on this part?
Yes, please.
Yeah. So what we are trying to do is, we are talk about so many terms of digitalization, right? We are adding so many layers, adding complex things, right? But the things which we didn't understand is, we are right now talking about Industry 4.0 and smart factory, connected factory. MG comes up with this saying that connected cars, right? Nobody talks about the deskless worker who's actually working in the ground floor, right? That's the disconnected worker. We want to connect them. So that's the platform we call it as a connected worker, and how the worker is getting connected through an expert, and how the worker life and the journey has to be transformed in from the digital, right? He is working in and around, tirelessly executing inspections, operation rounds, so many things. Nobody is accountable for it. Let's give some tools, probably in the phone, or maybe smart AR glasses, where wherever he finds problem, he directly connects back to an expert and his job gets done. And everything has been recorded. That's where the Plutomen Connect, and where it's remote audio visual assistance. In the same time, we need to think about aging infrastructure, right? We are adding more and more. Infrastructure is getting complex. But how to maintain it? We are still relying on the field force, right? And the same time, it is not exactly everything is running on piece of pen and paper still. If you talk about any big organization, when they talk about digital transformation, they're just saying, we have implemented SAP, we are upgrading SAP S4HANA, we are putting a bunch of HRMS systems. And now IoT comes up, you are adding more layers, more sensors, right? Complexity, where is a worker skill gap? He's not educated, right? How this needs to be done? So the thing is, we first need to connect the disconnect worker. So that's why the connected worker comes. And if you still going ahead and wants to do an hands-free operations, then the device comes.
Exactly.
Operated within voice commands, okay, and everything transforms. This is called an assisted reality, but now going from assisted to mixed and virtual, it's another step. Virtual generally comes with specifically from the training side. How we can transform this particular worker, not showing anything, he just wear the probably headgears and he goes into that different world and he actually understands what is the optimization we are doing at the shop floor. I mean, yeah. So
correct.
That's what it is. Yeah.
Yes.
Yeah, Rahul, over to you.
Yes, yes, yes. So what it means is that the worker on the ground who is somewhere, say, 200 feet on a tower and trying to do certain things and expecting him to either remember or write notes or maybe open up his mobile app and, do enter something.
Perfect.
Not required. Just wear this headgear, that's all. And this is all completely voice enabled, which means if you have a form, I want to fill up the form, I can simply tell him, fill up the form, yes, no, 100, 200. Everything is possible. And many of the utility companies here are using this technology as we speak.
Yeah, just to probably name, we have already executed pilot with Tata Power.
Tata Power, yeah, yes. They are at the always, I was listening to them always at the behest of new technology, new innovation. Some of the second aspect of this is for the utility companies to think of it. Look, when you think of actually looking at innovation just cannot be just purely software.
Absolutely.
You have to also see that this hardware being accelerated at a speed which is much higher than software. Please understand, your mobile phones, when you see 10 years back, were they this powerful? Hardware acceleration is way faster than you get the software updates. I promise you, Facebook hasn't gotten the number of updates that your iPhone got in the last 10 years.
Correct.
Trust me. Trust me. So, with these devices, we're here, we are at the booth, and we'll be happy to take your questions. If you need anything specific from us with respect to your business solution, happy to answer that. Any questions are welcome. Thank you very much. I hope I've been able to manage from the time as well.
Perfect. Thank you very much.
Thank you.
Thanks to you.
Thank you, Rahul and Rag. So wonderful, and I'm sure you have created a lot of curiosity in the audience. There'll be a lot of questions coming in.
But happy to take questions. Thank you.
We have to close the session. I think, sir, if with your permission, do we keep 5 minutes for question answers? Yeah. Or would you like to say something before we open the floor, or you'll end? Okay. So I am opening the floor for questions. Mics, please. To Rajan sir first, please. Yeah.
Technological innovations are always required, but my question is to Rahul. In fact, he's like in Minority Report, Tom Cruise this side, and his colleague, Cyborg, so that I think Van Damme this side. So, are we, simplifying the complexities to the, simple thing? Or the simple thing what we can do are making complex? Any technological intervention should definitely, result into bringing complex thing to the simplicity. And it should also have a cost optimization into our thinking. Of course, in fact, with the technology interventions, in fact, over a period of time, perhaps, the investment is meaningful. But what is your view regarding this? Whether this, your augmented reality, in what way it will help us into a power sector to make it more cost effective plus productive?
Okay. I'll give you a business case right away. If you're convinced, we'll discuss business with you. Service centers, you've got many service centers. In service centers, you get, let's say you've got 500 service centers for any utility company, and you get one type of query. Three times a month, and every time that's the same query, which means you've got 1,200 queries unique in service centers across. Every time your technician works on them, rethinks, redocuments, have the same process being repeated. By having connected worker, you have either with the headgear, because this works on mobile too. Tom Cruise uses mobile also. See, he drives a car too. But that was nice one, trust me, I loved it. The connected worker now has the opportunity to connect with the expert just with the use of a cell phone or a connected device like RealWear or Vuzix. If you take into account the time he spends equals to the money for one of the auto sector companies that we have done research with, the leadership team, we found they can save 12 crore rupees a year just on one single query that repeats with the same equation which I have told you. This is one of the largest automobile companies in the world. So it is going to be starting small. It's never going to be very big, which means when you buy a headgear, you won't buy 1,000. You'll buy 3. You'll test them out. Like when you buy a SAP, you never buy SAP R3. Like tomorrow, you go SAP small version.
Please, a little shorter answer.
Absolutely.
Then we have to move to another.
Finally.
So did he answer your question?
Finally, if you are.
What you were asking?
Anything else?
Okay.
I will also subsequently interact.
Sure.
Thank you.
Thank you. Anyone else? Questions from our panelists here? Yes, please.
So, good evening all. It has been a nice session since yesterday. So myself, Vallabrao, representing Phytech Embedded. So we are more from a semiconductor domain. Maybe like I don't know whether it's a question or a suggestion. Mainly to the AWS team and the officials, so like government officials or distribution authorities. The models or the AI modules which we have presented. So is there any opportunity to run them on-premise? Like, so there are a lot of enterprise licenses or so. So where these models can be run on on-prem servers, that is number one. These models, I know there would be a lot of Indian engineers, and then if you count the number of AI and ML engineers on the world, I believe there would be a lot of Indian engineers. So is there any opportunity of specific engineering team who can sit in India so that the data in India is dealt by Indian engineers? Of course, there could be a cross, the discussion between the team, and so I believe this could be possible, not by individual distribution company, but if the government or policy makers or so they come, I believe it could be a trade-off. So AWS team versus Indian authorities, I say.
Anyone would like to say anything to that?
On the first part, which is about running AML on-premise. Running AML on-premise, I think, like I was saying, the best place to run analytics or AML is the cloud because of the scale of data that is there, right? We're talking about data in petabytes, and how much more will you scale on-premise?
Once the data centers are there, I believe they are.
How many data centers and how much? And is it really cost effective if you build data centers on your own, right? So that is one aspect.
It's a national-wide. It's a national-wide. It's not to a one distribution, basically.
Yeah. Now coming to the second point, which I'm assuming is a question on data sovereignty or privacy with respect to data, training the model. I think all the cloud vendors comply to the laws of the land and comply to the data sovereignty norms, and we build our infrastructure, we build our services in such a way that we obey all the sovereignty norms, right? So there won't be any question of not following the sovereignty.
It's not about the policies or like the current policies which the cloud vendors do, but it's about the request.
I think this discussion you take up offline. I request you, we don't have much time.
Thank you.
But thank you for your question. And should we close the session, sir, or?
Before we close the session, I have a question. And the question is about the technology. There was multiple presentations made by several speakers talking about preventive maintenance, deploying of sensors, whether it is in the cable, underground cabling, or even on the preventive maintenance for the distribution transformers. What I have gathered, and with the limited knowledge that I have, when you do underground cabling, it is about 10x to 15x cost of the cabling. And then there are challenges of keeping track of where we have laid the cable, and there are multiple utilities working simultaneously, digging up the roads, and times come when you suddenly have a disruption because somebody has cut the cable. When we talk about transformers, the cost of sensor is much higher than the transformer itself. So when we talk about preventive maintenance, deploying sensors, technology exists, I do agree. But how do you address the cost competencies? Because if the distribution companies are not able to fend for themselves to supply or upgrade the capacities of the transformer, we are talking about a preventive transformers, which is DTRs, which is 25 kVA, 63 kVA, or 100 kVA. We understand particularly well in PTRs, but in the distribution transformers, having sensors and getting to work on them. And one of the points that Meenakshi ji made is about self-healing. I could not, frankly speaking, understand how self-healing starts. So these are the questions that we probably would have to answer, and if there is somebody who can respond to these questions, because this intrigues me that if I want to take this up as a utility or as a distribution company, how do I justify the investment that I am going to make versus the outcome or the benefits that the distribution companies would make?
Hello.
So, to respond to your question in terms of the underground cabling part, so if you see in Mumbai, the cost of actually digging up and reinstating is almost 10,000 rupees per meter. So, you are actually talking about the cost of the cable 4 times. Now, if you have to dig that cable for just identification and repairing it, what are you spending? You are actually spending another cable. So, when you actually what you call trace this cable with this technology that you're laying, and that is just a fiber link that you're putting across, which is 0.1% of the whole cost of it. So from that point of view is what I'm trying to tell you.
Another very, very interesting case. So this is only very interesting case, and especially when you said that you've done the whole feeder-wise smart metering this one. So that means the transformers have been also provided with smart meters. Now what we have done in TPDDL, we have provided DIDOs in the transformer connected smart meters, which we are using to get the data of the transformer. So we are not making any additional investment when we are talking about the transformer health monitoring. And that's a very good use case which can be adopted across. So it's basically, and that's what I would just go on this, it's also an optimization. See, we are in the DISCOM business. We don't have money to spend. Everything has to be optimized. So whatever technology we are using, we should make sure that we are extracting the maximum out of it. So this is a very important thing. And just for you, I just took that case when you said that it's an excellent initiative, which you said that feeder-wise this one. So the transformer where you're putting the smart meter, just add DIDOs, collect the transformer sensor data. Sensors cost peanuts. It's not much. At least you can protect 250 kV and above transformers. Not smaller ones, which again is the cost effectiveness which you can bring in.
DIDO, like what Devan is saying. So we have done the same thing, and we have tested on the 200 kV envelope. Okay, so definitely I am not adding more things, because the sensors are very cheap nowadays, less than 2,000 rupees. So you put the sensor, and definitely that will be the value addition.
close now? Thank you very much. It only switches on when the intelligent person arrives on the platform. So it was waiting for me to arrive. Thank you very much, the esteemed panel. There was a lot of insights personally which I could gather from the discussion that happened. I am sure that same would have been the case with almost all the present dignitaries here. A lot of people have talked about digitalization. We have talked about some of the references about the sensors being used for maintaining the health of our systems. We talked about AWS mechanism whereby AI/ML will give the real-time insights into decision making. Manish Patel ji also spoke about covered conductors and how it's not only a solution but as a challenge because there is a temperature rise and other things happen. Mr. Devanand and Mr. Chintamani spoke about underground cable. The sensors is not the small part. The sensors are not the only part, but the cable cost itself is a challenge. And but that is the way to go forward because we can't see hanging wires and on top of them the cable operators putting up their infrastructure, creating a very, very negative image about Indian distribution companies. Mr. Sunil Singh Senapati ji talked about from L&T, talked about preventive asset management, and I am thankful to them that they also were able to justify as to why and how we can do the management of these things. Meenakshi ji spoke about carbon conundrum and a reliable grid maintenance. So great that we have, and Vetrivel was talking about the digital substations, though we have experimented with Schneider, and we can actually have a discussion on how we can further improvise that so as to minimize those costs, because when we have this digital substations, the costs go up. So thank you very much, the esteemed panel. You have had done a marvelous job, and I must compliment Ms. Suri because she was the timekeeper and she ensured that we conclude this session in time. And just because of her that, I'm sorry about the speakers not getting enough time, but that is how we should be running our business, and she was very businesslike. And thank you very much for giving the opportunity to chair this esteemed panel. And I am personally very, very thankful that I learned few things which I didn't know. And I hope that finally the metaverse would be some of the solutions we'll find in the metaverse. Of course, it's very interesting when you have augmented reality, but how it's going to be utilized more and more in the distribution company is something that we have to comprehend. Thank you very much. Thank you.
Thank you so much, sir, and a big round of applause. We tried our best, and we'll conclude now. Thank you.
Thank you so much. We have the felicitation. May I ask Rajan sir to please come on stage? Jyotilal sir. Okay.
Both of you can come.
Yes, please. If both of you can come onto the stage, we can quickly do the felicitation of this entire panel. May I call Sanjay sir, the Chair, Secretary Energy Department, Government of Madhya Pradesh, to be felicitated by... To be felicitated. Sanjay sir. Sanjay sir would felicitate Devanand P. All three of them would felicitate. This session is rather funny. Devanand P. Sir, Chief Tech Services of PSCC, Chintamani Chitnis, Head Power System Control, Tata Power Company Limited. Thank you, sir. Who's this? Pritam sir? I'm not sure who's... Mr. Gopal. Mr. Gopal. That is me. Mr. Gopal Naria, Head Project Monitoring, BSES, Rajdhani Power Limited. Preetham. Mr. Preetham Mupuri, Business Development Manager, AWS India. Manish Patel. Mr. Manish Patel, Senior General Manager, Business Development, Apar Industries Limited. Mr. Sunil Kumar, Head of Business Segment, IASEA. SK Senapati, Head Sales and Commercial Services, L&T PTD Digital Energy Solutions. Meenakshi Vasisht, Co-founder and CEO, Tech Uncorked. Thank you. Vetrival. I had called out. Oh. Senapati ji. Mr. Senapati. Mr. SK Senapati, Head Sales and Commercial Services, L&T PTD Digital Energy Solutions. Thank you, sir. Vetrivel Kupusamy. I don't know what they're bringing. Vetrivel Kupusamy, Senior General Manager, Schneider Electric. And Mr. Rahul Sethi, Founder, Metaverse 911. Requesting all speakers to come forward for a picture to be clicked. While the click is happening, I would like to once again announce why we are rushing. The cruise dinner today from 7:30 to 10:30. The buses will depart from